Alright, this is prime factorization. So what does this mean? Well, let's just start with one first thing. What is a prime? What a prime is the number that when you multiply it, like if you have 31, the only numbers that will give you 31 is 31 and 1. If you had the number 5, 5 can only be made up of 5 and 1. A prime is a number, a whole number, greater than 1, with only 1 in itself as a factor. So this is what makes a prime. 5, 31. The only factors you're going to get for 31 are 31 and 1. The only factors you'll get for 5 are 5 and 1. It's prime. Like if you have the number 6, 6 is not prime, because 6 can be made up of 2 and 3. And that's what we want to do. We want to find out what the primes are for each number. And for every whole number greater than 1 is either prime or can be expressed as the product of primes uniquely. So what does that mean? It means there's one unique set for a number. So here's how we do it. The first thing is called a factor tree, and you've probably seen this before. You just need two numbers that when multiplied give you 140. So my first thought is, because it has a 0, I'm going to do 14 and 10. Now it doesn't matter how you choose this, because for every whole number greater than 1 it can be expressed as a product of primes uniquely. There's only one set. It's one answer. So for 14, that would be 2 and 7. Oh, both of those are prime. Once you hit a prime, you want to stop, circle it, and that is the primes. 10 is not prime because it can be made up of 2 and 5. Circle the 5, circle the 2. These are all primes. Factors of 2 is 2 and 1. Factors of 5 is 5 and 1. Factors of 7 is 7 and 1. And that's it. So our answer would be 2 squared, because we have 2 of them, times 5 times 7. That's our unique product of primes, and we call this prime factorization. Alright? So like, watch, I'll try it again with another one. 140, and you think, oh, well, 2 and 70. There's one prime. 70 would be 2 and 35. 35 would be 5 and 7. And if you notice, same 4 primes. Same 3 primes. 4 different numbers. 2 and 2, so 2 squared, 5 and 7. It doesn't matter how you choose, there's only one product of primes. Alright? This is one method. This is called the factor tree. The other method is called the ladder. So if you take 140, and what you do is you just look at the number 140. What prime do you know goes into there? So I know that a 2 goes into there because it's even. So 2 times 70. And then 70 has a 2 also. 2 times 35. And then what two numbers give you, what other prime goes into 35? Well, it has a 5 at the end. So it's 5 and 7. And once you get a prime at the end, those are all the numbers. And you notice we have 2 squared times 5 times 7. Same prime factorization, 2 different methods. So the ladder, you just take out factors. And to show you it again, we'll try it with different start, 140. Well, we know that there's a 5 in 140 because it ends in a 0. Right? So what number will go into there? 5 into 140, that would be, what is that, 28. And then 28, well, that has a 2. It's also got a 7. We'll start with 7. 7 times 4. 4 is still composite. So 2 goes into 4, and then we get a 2, and there it is. And notice, same 4 numbers. It doesn't make a difference on how you do this. If you like the ladder method, do the ladder method. If you like the factor tree, do the factor tree. Here is a bunch of problems for you to try. Alright, so give them a shot. In fact, why don't we try one together? We'll do 16 together. Give me 2 numbers that multiply to 16. Yes, you said 4 and 4. Very good. How did I know that? I don't know. I just guessed. 4 would be 2 times 2, prime, prime. 4 also, 2 times 2, prime, prime. So we have 2 to the 4th. That is our prime factorization. Here, let's pick a little different one. Which one do I want to do? I will do 250, because I like 250. Okay, so I see 25 and 10. And then I also see 5 and 5, and 2 and 5. So that gives us 2 times 5. There's 1, 2, 3 of them. Let's circle them all so we don't miss any. Cubed. And that is our prime factorization for 250. That is our prime, our product of primes. It's distinct for that number. So try the rest of these, okay? hit pause on your video, and then I'll write all the answers down. And again, if you don't like the factor tree, you like the ladder method, go ahead and do the ladder method. In fact, if you want, do them both. Can't hurt, right? But how do you know you have it correct? Well, you want to multiply it back out. 2 times 2 is 4, times 2 is 8, times 2 is 16. And then if we did 5, come down here, when you get 5 times 5, you get 25. 25 times 2 is 50, and 50 times 5 is 250. Or you could do 2 and 5 is 10, 5 and 5 is 25, and 25 and 10 is 250. But you want to multiply it back out. You can, if you have access to a calculator, check it with a calculator. So, all right, try them though. So hit pause. Now hit pause. All right, and here they are. So you should have had these answers. And again, you can pause at any time if you want to check them. But there they are. Those are what you should have had. If not, go back and correct it. If you have any questions, thank you.